Let's talk about Copernicus and Galileo and the birth of modern astronomy. So during medieval Europe, not a lot of scientific innovation happened in Europe. A lot of the innovation that did happen during this time came from the Islamic world. They did make some advancements. You'll read about that in your homework. Nicholas Copernicus was born in 1473 in what is now Poland and was Prussia at the time. He was many things: a monk, a mathematician, an astronomer, a translator, a governor, a diplomat, and that's just a small list of what he did with his life. He, at this point in time, Ptolemy's geocentric model was starting to show signs of inaccuracy. It was over 1,000 years old, and the predictions that he made many, many years ago were starting to not bear out by observation. So Copernicus developed a sun-centered model of the universe, heliocentric. People at the time had a really hard time believing that the Earth was moving because, as you know, we don't feel the motion of the Earth as it does move, but it's moving very fast, like 30,000 kilometers per second. So this heliocentric model was revolutionary. It was a new idea for European scientific thought at the time. So here is one of Copernicus's drawings of his model. It placed the sun at the center, hence the heliocentric name. He argued that the celestial sphere could actually be explained by the Earth's rotation inside of the universe. So the motion of the objects in our sky was really because Earth is spinning on its axis, rather than all of these objects moving around us. He correctly placed the known planets: Mercury closest to the sun, Venus a little further, and then Earth, and then Mars, and then Jupiter and Saturn. He deduced that the closer planets are to the sun, the faster their orbital speed. So they're actually moving faster around the sun as they orbit the sun. And he correctly explained retrograde motion without epicycles. But his model was not perfect. He assumed that all of these orbits around the sun were perfect circles. And this had a lot to do with the belief that the universe was divinely created, and nothing that was divinely created could have imperfect circular motion. So everything moved in perfect circles. And it didn't perfectly match data, especially data that came a little bit later. It didn't perfectly describe the orbit of Mars, and we'll talk about why a little later. And eventually, data revealed this flaw. So Copernicus' theory did not win out at the time. Religious teachings emphasized that scientific thought was to be doubted, that you should learn about the world around you and the universe only from the church, and scientific inquiry was suspect. There weren't very many scientists who were testing Copernicus's hypothesis and collecting data to see if his predictions were accurate at the time. So the geocentric model continued to be the prevailing model of the solar system for about 100 more years until Galilei, who was born in 1564 in Pisa, Italy. You guys have heard about Galileo's study of the motion of objects. He's the guy that dropped two different objects off of the Leaning Tower of Pisa and noticed that they fell more or less at the same rate. He did lots of other experiments about motion, and laid the groundwork for Isaac Newton's laws of motion. He challenged the church's teaching that the Earth was the center of the universe, and then the church, as thanks, considered him to be dangerous and prohibited the teachings of the Copernican heliocentric model in the year 1616. Galileo made many contributions to astronomy. He built one of the first telescopes. It was more like a spyglass, and most people used them to look at nearby objects, but Galileo used the spyglass to look at the sky at night and was able to see more points of light that, especially in the Milky Way, which looks like this kind of like gooey of light in the sky, like a giant nebula. But really, if you look at it more closely, it resolves into tons and tons of little points of light. And each of these points of light is a star in the Milky Way galaxy. Um, he noticed the presence of moons orbiting Jupiter, which removed one of the arguments against the heliocentric model, the belief that a moon could not orbit a planet because it wouldn't be able to keep up with the planet's orbit around the sun. So they believed, hence, that those objects must be orbiting the Earth, or the moon must be orbiting the Earth. But Galileo discovered that Jupiter actually had a moon, and actually has many moons orbiting it. And so, if moons could orbit Jupiter, then while Jupiter orbits something else, then Earth could also have a moon orbiting it while Earth orbits the sun. So, this helped to support the heliocentric model. So the people of his time thanked Galileo for his discoveries by sentencing him to house arrest. They banned his books and found his work to be heretical. This is the Catholic Church found his works to be heretical until the year 1992. This was the year I was in 8th grade, so this is not that long ago. And today we contribute the work of Galileo and Copernicus to what we now call the Copernican Revolution. And here is a timeline of heliocentrism on the top and geocentrism on the bottom, and the people that believed in each one. So we have some ancient Greeks who were supporters of heliocentrism long before Copernicus came along. Aristotle was a geocentrist, Ptolemy was a geocentrist, and the times where they were studying astronomy. Many years where, at least in European thought, there wasn't a whole lot of astronomy happening. And then along comes Nicholas Copernicus. Soon we'll be talking about Tycho Brahe and Kepler and so on. All until right before 2000, the Catholic Church was like, okay, maybe you guys are kind of right. All right, see you guys later.